That's the caldera of a volcano, like this Yellowstone thing. We thought it was just this crazy place with hot springs. Like, no, that's a super volcano that is a continent killer. And it blows every 600,000 to 800,000 years, and everyone dies. Like, the whole country dies. And it happens every 600,000 to 800,000 years. The last time it happened was like 600,000.
The geysers, hot springs, and mud pots make Yellowstone one of the most geologically active places on Earth. But beneath this breathtaking landscape lies a supervolcano.
Yellowstone National Park. We think of Yogi Bear, we think of Old Faithful, but underneath that park, there is a ticking time bomb.
A monstrous force of nature that erupts every 600,000 to 800,000 years, blanketing the world in ash. Now, unprecedented seismic activity has left experts scrambling for answers as they analyze the data. The public is on edge, eyes glued to news reports, hearts pounding with a single unspoken question. Is this sleeping giant waking up? Join us for an exclusive tour, revealing the terrifying discovery at Yellowstone that has caused residents to flee in panic. Tremors in Yellowstone. Yellowstone has recently been shaken by hundreds of earthquakes. Though most tremors are too small to feel, their presence is unsettling. This region is no stranger to swarms of earthquakes, experiencing them annually. What's particularly fascinating and alarming is that 2/3 of these quakes occur between Hebgen Lake and the Yellowstone caldera, tracing a buried fracture zone from the super eruption 2.1 million years ago. The recent spike in seismic activity has scientists on edge, fearing it could be a precursor to a larger, more destructive event that might threaten human lives. Among the most significant recent swarms were 147 quakes, just a few miles east-southeast of West Yellowstone, Montana, and another 106 beneath the northern part of Yellowstone Lake. These swarms are often triggered by the interaction between groundwater and existing faults. Adding to the tension, noteworthy hydrothermal unrest unfolded from May through June 2023. Previously dormant features sprang to life, and new ones emerged on Geyser Hill near the iconic Old Faithful geyser. The situation grew so intense that part of the boardwalk had to be closed to visitors as hot water and debris splashed onto the walkway. Investigations revealed that this burst of activity was driven by changes deep within the volcanic chamber. Scientists are no longer asking if Yellowstone's volcano will erupt again, but when and whether we'll be prepared. As they meticulously monitor these tremors and the forces lurking beneath the surface, the world watches with growing unease. The next major eruption could transform our world in unimaginable ways. Yet despite intense scrutiny, humanity might still be caught off guard. The urgency stems from an alarming discovery. Magma is accumulating far faster than scientists ever predicted. This accelerated rate raises the stakes, adding a sense of impending danger. While predicting the exact timing of the next eruption remains elusive, scientists remain vigilant, continually preparing for the possible cataclysm. As they study the rumblings beneath Yellowstone, the question looms: will we be ready when the sleeping giant awakens? The last super eruptions. Examinations of the volcano's distant past offer tantalizing clues as to when to expect a possible eruption. Geologic evidence reveals that Yellowstone has unleashed 3 colossal eruptions in the last 2.1 million years, with intervals of 600,000 to 800,000 years between each cataclysm. The last massive event, about 640,000 years ago, left scars that stretch across the park and thousands of kilometers beyond. Scientists cannot predict the exact future of Yellowstone, but they have an idea, and many believe it's unlikely to spell doomsday. Dr. Jacob Lowenstern, research geologist and scientist in charge at the Yellowstone Volcano Observatory, reassures that Yellowstone is currently a dormant volcano, exhibiting only low levels of unrest. According to the USGS, Yellowstone's last 3 catastrophic eruptions ejected enough ash and lava to fill the Grand Canyon, and the most recent created a colossal crater spanning 30 by 45 miles. Although the odds of such an eruption occurring today are slim, about 1 in 700,000 each year, the potential devastation would be unimaginable. After each of these colossal eruptions, the Yellowstone supervolcano imploded, swallowing trees, mountains, and everything in its path. This dramatic collapse forms a vast depression known as a caldera. Hence, the Yellowstone supervolcano is also referred to as the Yellowstone caldera. These cataclysmic events have shaped the eastern part of the Snake River Plain, transforming a once mountainous region into its current form. The USGS also estimates that the last Yellowstone eruption was 1,000 times more powerful than the infamous 1980 Mount St. Helens eruption, which killed 56 people, thousands of animals, and scorched hundreds of square kilometers in Washington and Oregon. The deadly plume of hot ash, molten rock, and lethal gases shot thousands of meters into the air, likely plunging a third of the continent into darkness. Pyroclastic flows, rapid torrents of hot rock fragments and gases, raced across the region, obliterating everything in their path. Magma spewed from the ground, scorching the once picturesque landscape for kilometers. The aftermath of this eruption is still visible today in the Yellowstone caldera, a massive depression 50 kilometers wide and 70 kilometers long. Thick volcanic debris, known as Lava Creek Tuff, remains as a testament to the eruption's fury. The Yellowstone Volcano Observatory suggests that future activity will more likely involve hydrothermal explosions, eruptions of steam and hot water, or lava flows rather than a catastrophic eruption. Although lava flows are a type of magmatic eruption, they lack the cataclysmic fury of caldera-forming explosions. Instead of instant devastation, lava flows creep menacingly, oozing out of the earth over days, months, or even years. Their slow advance belies the latent power beneath the surface. Since the last super-eruption, non-explosive lava eruptions and less violent explosions have occurred within and around the Yellowstone caldera. A dramatic eruption 174,000 years ago carved out the west thumb of Lake Yellowstone. Smaller, but still formidable, steam explosions happen from time to time. One such explosion, 13,800 years ago, left a massive 5-kilometer-wide crater at Mary Bay, near Yellowstone Lake's edge, right at the heart of the caldera. In 2013, earthquake data analysis revealed the staggering size of Yellowstone's magma chamber, 80 kilometers long, 20 kilometers wide, and holding an underground volume of 4,000 cubic kilometers. While only 6 to 8% of this chamber is molten rock, making a super eruption seem unlikely, the chamber is much larger than scientists had previously thought. Then, in October 2018, research from Arizona State University uncovered startling findings. Crystals from Yellowstone's lava revealed that before the last super eruption, the magma chamber experienced rapid temperature increases and changes in composition due to 2 large influxes of magma. This analysis suggests that Yellowstone's magma reservoir can reach a super eruption state within mere decades, not centuries as once believed. The Yellowstone caldera. As mentioned earlier, the Yellowstone caldera is a vast depression formed during the last of 3 super eruptions over the past 2.1 million years. These massive eruptions have not only shaped Yellowstone National Park, but have also significantly impacted the entire region, leaving a lasting legacy that geologists and scientists continue to study. While some geological activities end with an earthquake or an eruption, Yellowstone's story didn't stop there. Instead, it continued with the formation of resurgent domes, a fascinating and significant geological phenomenon. After the last super eruption, the emptied magma chamber beneath the caldera began to refill. This led to the creation of resurgent domes. As magma accumulated, it caused the caldera floor to swell upwards, forming 2 large dome-shaped uplifts, the Sour Creek Dome and the Mallard Lake Dome. To visualize this, imagine a giant underground balloon filling with magma, or molten rock. As this balloon expands, it pushes up the ground above, similar to how a bubble forms in baking dough. These resurgent domes are not small bumps in the landscape. Each one stretches over 10 kilometers in width and rises hundreds of meters above the caldera floor. Although they were formed simultaneously, the Sour Creek and Mallard Lake domes have distinct histories and structures. The Sour Creek Dome rose above the adjacent caldera rim before its uplift ceased. Imagine a giant mound that grew until it couldn't grow anymore. Its surface is crisscrossed by numerous faults, which are cracks that formed when the dome pushed up against the surrounding rock, responding to intense upwarping forces. In contrast, The Mallard Lake Dome experienced an early uplift and then a significant resurgence about 170,000 years ago. This later episode included the eruption of the Mallard Lake rhyolite flow, which added a new layer of rock to most of the dome's surface, increasing its volume. These domes are not simple hills. They are complex geological features with dynamic histories. Understanding them is crucial for comprehending the park's current geothermal activity and potential future volcanic events. The uplift and deformation of the caldera floor, as evidenced by these domes, suggests that the Yellowstone volcanic system is far from dormant. An eruption of the Yellowstone caldera would be extremely dangerous, potentially more so than lava alone. Despite reassurances from experts, the potential for a catastrophic eruption at Yellowstone is a serious concern. This scenario could disrupt global climate patterns, lead to food shortages, and worsen environmental problems. Interestingly, Yellowstone's bison may even help predict earthquakes, adding another layer of intrigue to this dynamic geological landscape. How deadly could volcanic ash be? If a volcano as active and large as Yellowstone erupts, the spread of volcanic ash would be on a global scale. Imagine it like an eclipse of the sun. Daylight would turn into complete darkness as plumes of volcanic ash spread over vast areas of the sky, drastically reducing visibility. These enormous clouds are often accompanied by thunder and lightning, a phenomenon known as volcanic lightning. Volcanic lightning is unique and not fully understood. Scientists believe the immense energy of a volcanic explosion charges ash particles with electricity. When positively and negatively charged particles meet, either in the cooler atmosphere or within the volcanic debris, lightning bolts occur to balance these charges. Volcanic ash and gases can reach the stratosphere, the upper layer of Earth's atmosphere. This debris can reflect incoming solar radiation and absorb outgoing land radiation, cooling the Earth's temperature. In extreme cases, these volcanic winters can disrupt weather patterns globally. For example, the 1815 eruption of Mount Tambora in Indonesia injected an estimated 150 cubic kilometers of debris into the air. This caused the average global temperature to drop by as much as 3 degrees Celsius, leading to extreme weather conditions worldwide for 3 years. North America and Europe experienced the year without a summer in 1816 as a result of Mount Tambora's ash. Airborne volcanic ash poses significant danger, particularly to moving aircraft. The tiny abrasive particles of rock and glass can melt inside airplane engines and solidify on turbine blades, leading to engine stalls. Therefore, air traffic controllers implement special precautions when volcanic ash is present. The 2010 eruption of Eyjafjallajökull in Iceland created an ash cloud that resulted in the cancellation of roughly 100,000 flights and impacted 7 million passengers, costing the aviation industry an estimated $2.6 billion. Volcanic ash can also have a profound impact on the infrastructure of entire communities and regions. It can disrupt machinery and power supply, water supply, sewage treatment, and communication facilities. Heavy ash falls can hinder road and rail traffic, damage vehicles, and, when mixed with rainfall, form a heavy, cement-like sludge that can collapse roofs. For instance, during the 1991 eruption of Mount Pinatubo in the Philippines, heavy rains mixed with ash fall caused the collapse of roofs in houses, schools, businesses, and hospitals in 3 different provinces. Moreover, volcanic ash poses a threat to ecosystems, including people and animals. It contains carbon dioxide and fluorine, which can be toxic to humans. Ash fall can lead to crop failure, animal death and deformity, and human illness. The abrasive particles of ash can also cause discomfort and inflammation when they come into contact with the skin and eyes. Inhalation of volcanic ash can cause breathing problems and lung damage. Inhaling large amounts of ash and volcanic glass can even lead to suffocation, which is the most common cause of death from a volcano. The farther the ash travels, the more destruction it brings. Can we stop Yellowstone from erupting? It seems as though it has gotten to the point where extreme measures need to be taken to ensure survival. In some cases, limited scientific drilling for research can help scientists understand hot water systems. However, drilling to prevent a volcanic threat is simply a no-entry zone. It is a much different subject with great unknown consequences, high costs, and severe environmental impacts, in addition to the enormous expense and technological difficulties in drilling through hot, mushy rock. Drilling is unlikely to have much effect on whatever magma is stored beneath Yellowstone. At near magmatic temperatures and pressures, any hole would rapidly become sealed by minerals crystallizing from the natural fluids that are present at those depths, which might even make the drilling meaningless. Also, Yellowstone National Park is protected from geothermal resource development. As earlier mentioned, famous natural features like Old Faithful Geyser and Grand Prismatic Spring depend on heat provided by the magma chamber deep below Yellowstone's surface. Any geothermal extraction would lower the pressure on the existing geysers and hot springs, altering their behavior and, in many cases, causing them to disappear. Some major concerns about volcanic eruptions at Yellowstone typically revolve around a caldera-forming event. Many people are worried that another eruption will happen soon, forming yet another caldera, but it's still largely unknown whether any eruption of such magnitude will ever occur there again. Current seismic imaging of the magma reservoir reveals a system that is too crystalline to erupt on a grand scale. Even if there were significant eruptible magma underneath Yellowstone, drilling into it in an attempt to release the pressure would have disastrous consequences. The scary part of attempting such a drill is that recent scientific research has proven over and over again that releasing the pressure is one of the factors that drives magma toward the surface to erupt. So attempts at cooling and depressurizing magma systems would have many unintended negative consequences, including making a super eruption more likely. It is important, therefore, to note that a program of large-scale magma quenching will not be undertaken at Yellowstone or elsewhere for that matter in the foreseeable future. Some people who are concerned about the activities happening at Yellowstone happen to be least concerned about the beautiful scenery or breathtaking landscape. The major concerns are two major questions: when the volcano will erupt and whether we will survive it. When will the Yellowstone volcano erupt? Some media reports have often inflicted fear in people by claiming that Yellowstone is due for an eruption. According to them, the reason for their claim is that because the last eruption of the supervolcano was 70,000 years ago, it's bound to blow soon. But according to researchers, that's not how volcanoes work. This is perhaps the most common misconception about Yellowstone, and probably about volcanoes in general. However, volcanoes don't work on timelines. It's rather the opposite. According to Michael Poland, a geophysicist and the scientist in charge at Yellowstone Volcano Observatory, in an email to Live Science, volcanoes erupt when there is enough eruptible magma beneath the surface and pressure to cause that magma to ascend. As of yet, neither condition is in place at Yellowstone right now. Since the eruption is highly dependent on the magma supply, if that factor is cut off, then the volcano won't erupt. Poland further emphasized that many volcanoes go through cycles of activity and inactivity. More often than not, a volcano's activity is a direct consequence of the magma supply. Some volcanoes seem to have regular eruptions, but this is because the magma supply is relatively constant, like the eruptions of Kilauea in Hawaii or Stromboli in Italy. If this is the case, then the question is, where does the idea of Yellowstone being overdue for an eruption come from? Poland suspects that the idea of the volcano being overdue comes from the concept of earthquakes. Earthquakes happen as stress accumulates on faults, and in many places, this stress accumulates at a relatively constant rate due to, maybe, plate motion. That being the case, one might expect earthquakes to occur at somewhat regular intervals. But it is more complicated than that. There are many variables at play. But for that reason, it makes more sense to say that a fault is overdue for an earthquake rather than a volcanic eruption. According to Poland, Yellowstone is very well monitored by a variety of techniques. It is covered in terms of seismicity and ground deformation. The scientists monitoring the area track the temperatures of some thermal features, although this is not necessarily an indicator of volcanic activity, but rather of the behavior of specific hydrothermal areas. We look at overall thermal emissions from space, collect gas and water to assess chemistry over time, and track stream or river flow and chemistry. By and large, Yellowstone is relatively stable right now and has not displayed any unusual seismic activity lately. But this doesn't mean the volcano would continue to remain dormant. If it decides to erupt, the consequences could be extremely great. Some volcanologists are of the opinion that the ramification they are most concerned about is wind-flung ash, which could end up shrouding a surrounding region 500 miles across in more than 4 inches of ash. Experts predict that this could result in the short-term destruction of Midwest agriculture and leave scores of watercourses clogged. According to the United States Department of the Interior, the surrounding states of Montana, Idaho, and Wyoming that are closest to Yellowstone would be gravely affected by pyroclastic flows, while other places in the United States would be impacted by falling ash. Poland added that the effects would also be felt beyond the borders of the United States. As for when this monster will erupt, no one knows. It could be soon, but again, it could be after several lifetimes. Volcanoes are not very predictable, after all. The deadliest underwater volcano. Recent reports reveal a chilling development beyond the looming threat of the Yellowstone volcano. Thick volcanic dust now blankets Tonga's capital, Nuku'alofa, signaling an ominous awakening. The Tonga Ha'apai volcano has ominously cracked open and teeters on the brink of eruption. While investigations into this unfolding crisis are underway, one thing is certain. The probability of this feared volcano erupting has surged to a staggering 360%, boasting a volcanic explosivity index of 6, rivaling the catastrophic Krakatoa eruption of the 19th century. This grim reality has thrust the world into a state of urgent readiness as it braces to confront this imminent peril. This cone-shaped submarine volcano lurks beneath the depths, nestled amidst the 171 islands comprising the Kingdom of Tonga. It lies approximately 500 feet below sea level, stretching 2.5 miles in length and spanning a mile in width. Its base, measuring around 20 kilometers in diameter, propels toward the ocean's surface, towering at an imposing height of approximately 2,000 meters. With its history traced back to eruptions as far-reaching as 1108 CE, the volcano has left an indelible mark on the landscape. The most recent eruptions, occurring between 2021 and 2022, pale in comparison to the impending cataclysm. Yet, even these lesser eruptions have wielded significant influence, notably impacting the planet's fragile ozone layer. In the past century, this volcano has unleashed periodic eruptions, each one marking a terrifying chapter in its volatile history. The first significant eruption roared to life in 1912, followed by another tumultuous event in 1937, leaving a trail of destruction in its wake. Yet, it was in March 2009 that the volcano embarked on a sinister trend of unprecedented violence. March 2009 witnessed the eruption's ominous escalation as it unleashed a ferocious display of power, hurling volcanic ash thousands of feet into the heavens. Tonga's chief geologist, Kalepi Mafi, recounted how the eruption shrouded Hunga Harbor Island in a blanket of thick black ash, obliterating all in its path and sculpting new land as it devoured the surrounding vegetation. The ominous drumbeat continued with the 2014 eruption, a seismic symphony that commenced with a haunting prelude of earthquakes echoing beneath the Earth's surface. These tremors, stretching over several harrowing weeks, served as a chilling harbinger of the cataclysmic eruption that followed. The main event unleashed a towering white steam plume, a spectral specter rising from the ocean's depths to dominate the skyline. Local fishermen gazed in awe and terror as this monstrous display unfolded before their eyes, casting a shadow of fear across the region. This eruption did not go unnoticed by the scientific community. Geologists Cecil Sabel and Damien Gruya embarked on a daring expedition to gather volcanic rock samples from the heart of the inferno. Their courageous efforts paved the way for NASA's intensive study of these samples, unlocking crucial insights into the enigmatic workings of the Tonga Ha'apai volcanoes and shedding light on the mysteries of island formation. Yet, despite the exhaustive research and meticulous analysis, the world found itself on the precipice of an unprecedented crisis on December 20th, 2021. The eruption that ensued was a cataclysmic spectacle of unparalleled fury, unleashing a maelstrom of ash and chaos that reached even the distant shores of Nuku'alofa, 110 miles away. The Volcanic Ash Advisory Center in Wellington scrambled to reroute aircraft away from the impending danger zone, a last-minute maneuver to avoid a collision course with nature's wrath. Just when the world dared to breathe a tentative sigh of relief on January 11th, deeming the volcano dormant after over 2 weeks of relentless fury, nature unleashed a fresh wave of terror on January 14th. The eruption that followed defied all expectations, casting the sky into a hellish inferno as volcanic ash soared to staggering heights, reaching a chilling pinnacle of 12 miles above the Earth's surface. But the horrors did not end there. On January 15th, the eruption breached new frontiers of devastation, unleashing a cataclysmic display of power that shook the very foundations of the world. Ash plumes ascended to unimaginable heights, soaring an astonishing 36 miles into the heavens, carving a path of destruction that spanned continents. These monstrous plumes birthed atmospheric waves that encircled the globe at a dizzying speed of 720 miles per hour. The explosive force of the eruption birthed tsunami waves that surged with a relentless ferocity, engulfing everything in their path with a merciless embrace. Tonga's Tafua Island bore the brunt of nature's wrath as towering waves, reaching a spine-chilling height of 148 feet, crashed upon its shores, leaving destruction in their wake. On Tonga Tapu, the waves reached a staggering 56 feet, plunging coastal communities into chaos and despair. As the water vapor released into the sky equaled the volume of 58,000 swimming pools, the scale of devastation became painfully apparent. The series of tsunamis and lightning strikes that followed the eruption unleashed a maelstrom of destruction, displacing over 80% of Tonga's population in a cruel twist of fate. Reports from Sky News painted a harrowing picture of the aftermath. Coastal areas ravaged by relentless waves, small islands submerged beneath the relentless tide, and communities left grappling with the suffocating embrace of volcanic ash. Atata, a once thriving island near the capital, lay submerged underwater, its residents gasping for breath amidst the choking haze of ash. Mango Island lay in ruins, its once proud structures reduced to rubble, while neighboring Fonoifua Island stood as a haunting testament to nature's indiscriminate wrath, with only 2 buildings left standing amidst the desolation. On the west coast of Tonga Tapu, 21 homes lay in ruins, their foundations shattered by the relentless onslaught of nature's fury. The waterfront of Nuku'alofa, once a bustling hub of life, now lay desolate and barren, its streets haunted by the echoes of despair and loss. Amidst the wreckage, reports of missing individuals added a poignant layer of tragedy to the unfolding devastation, as communities grappled with the harsh reality of their shattered existence. Thanks for watching. See you in the next video.